the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. In this video, I'll do a brief review of the slope-intercept form of a line. This topic is 2 levels below transfer level mathematics, and as such, this review will be very short. So, let's get started. There are many ways to graph a line. For example, you could have been given 2 points, and all you'd need to do is draw a line going through these 2 points, and that's pretty much it. It's pretty simple. Another way you could graph a line is to have a starting point, and then once given a slope, use that slope to find another point on the line. We know from our previous material that slope is rise over run. And so if we're initially handed the point -3, 7, and the slope of the line going through that point as -2/3, we should know that if we start at the given point, -3, 7, we can then use the slope to fall 2 steps and run 3 steps. And we'd arrive at 0, 5 as the second point on our line. In both examples, I didn't actually give you the equation of the line. I just gave you some information. But we can use that information to form the equation of the line, and that is the point of this video. The slope-intercept form of a line is y equals mx plus b. It is by far the most popular form of a line among algebra students, mainly because it gets drilled into your head in middle school. As we all can easily recite, m is the slope and b is the vertical intercept. That last statement needs to be repeated. The constant term in the slope-intercept form of a line represents the vertical intercept, or what I call the time zero value. But I'll talk about that more in future examples. It's common for people to think that you only use the slope-intercept form of a line when given a slope and, well, a vertical intercept. However, this form can be used anytime that the point-slope form can be used. Not all students know this, and I'll show you how to do this in our second example. Since this is a review video, I'm not going further into the instruction of why this is a slope-intercept form of a line or how it is derived. But you should already know pretty much all there is to know about this form, and if you're not sure, the examples I present here should probably jog your memory. You're selling a particularly valuable book online. The site you're using has a very, very unique selling structure. You as a seller, you get to list the item for the top price you want. We'll call this the ceiling. And you also state the absolute lowest price you're willing to take. We'll call this the floor. You then set an increment value. Every 15 minutes, the price will drop by that increment value. It's kind of a cool idea. If you have a hot item that a lot of people want, you can list it for an outrageous amount and just wait. Eventually, the price will dip low enough to entice someone to buy it before another person does. Now, let's say you have a limited edition signed copy of Robert Jordan's Eye of the World. This is part of the Wheel of Time series, a great series. Anyhow, you know this is sold elsewhere for $300. So you set a ceiling, the highest price that you possibly get, at $500. And you set the floor at $250. Remember, that's the lowest absolute price you will ever take for this. Now, you're a patient person, so you set the increment to $5. That is, the price will drop by $5 every 15 minutes. Write an equation for the current selling price of the book in terms of the number of hours that the book has been listed. Before we delve into this problem, notice the unit difference between what we were given and what we are asked. We were given that the price drops by $5 every 15 minutes, but we were asked to state the price in terms of the number of hours that have passed. This means we need to convert all time units into hours. Well, this is a simple conversion. $5 for every 15 minutes means $20 for every hour. But it is often the case that unit conversions are much messier than this. If you need to review unit conversion, please see the relevant prerequisite video in the links below. Now we can actually start working on the problem. Using our problem-solving skills from elementary and intermediate algebra, we know to initially define variables for the changing quantities. The 2 quantities that are changing in this situation are the price of the book and how many hours have gone by. I hope it's obvious that these rely on one another. Let P equal the price of the book at any moment, and H equal the number of hours that have passed. Since these are two variables, we can go ahead and graph a Cartesian coordinate system. And in this case, they're forcing your hand here by specifically stating they want the price in terms of the number of hours. Remember, the language following in terms of tells us our independent variable. So our independent variable is the number of hours that have passed. Therefore, our dependent variable is the current book price on the website. Let's go ahead and label the axes. If you are really rusty with lines, then it might be a good idea to write out the form of a random coordinate for this graph. The ordered pair is listed as independent variable, comma, dependent variable. So for us, our ordered pairs will be hours, comma, price. Or I'll just write it as H, comma, P. The only reason why I do that is because some students are really rusty with graphing skills. So I think it's very important for you to identify which variable is the independent and which variable is the dependent, and to clearly state that as an ordered pair. If we take a look at the given information, you might be able to decipher the fact that they have actually given us a point. At time 0, right as we list the book, the price is $500. Thus, 1 point on our graph must be 0, 500. Hour 0, price 500. Notice that this is the vertical intercept, also called the p-intercept for this graph, because the p-axis is the vertical axis. Honestly, if you're just being asked to find the equation of this line, most people would be able to read the intercept and technically the slope from the language of the question without the need to graph. But I like to dig deep into problems. Now, as a quick aside, and going back to what I mentioned at the beginning of this video, I call the vertical intercept the time 0 value. It represents the price of the book right when it gets listed. This is a great interpretation of the vertical intercept, and I encourage you to use it. Before we start talking about the slope, let's sketch a graph of what the price should look like as time goes on. We've already plotted 1 point, the vertical intercept, and we know that the price should fall as time goes on. So it should very roughly look like this. To be exact, however, we should use the given slope. If we look at the given information, they tell us that the price will drop by $5 every 15 minutes. This is a rate of change, also known as a slope. We need our equation written in terms of hours, not minutes, but we already performed the conversion, so losing $5 every 15 minutes, we know is the same as losing $20 every hour. I'm emphasizing the word losing because that means the slope is negative. Now, if we look at our units for the axes, we see that dollars over hours is definitely rise over run for this situation. That's because the vertical units are the dollars and the horizontal units are hours. Hence, the slope of our equation will be -20, and that's in dollars per hour. We actually have everything we need to answer the original question at this point. The vertical or p-intercept is 0, 500, and the slope is -20, again, dollars per hour. Inserting these into the slope-intercept form, we get P is equal to a -20h plus 500. If someone buys the book an hour and 45 minutes after the auction starts, we can compute our selling price by converting 1 hour and 45 minutes strictly into hours. So the conversion goes like this, and we get 1.75 hours. If we plug this in for H, we get 465 as the answer, but remember that answer represents the sale price. So if we have a buyer at 1.75 hours, we are selling that book for $465. If we wanted to know how long the book is going to be listed before hitting the floor price, remember that was $250, we just let P equal 250 in our equation and solve. In this case, we'll get H equals 12.5 or 12.5 hours. Therefore, we know that after 12.5 hours, our auction will have reached the floor price. And from that point forward, the lowest price we would take is that $250. Let's take a moment to expand our knowledge while using the slope-intercept form. Most textbooks cover finding the equation of a line in slope-intercept form if you're given the slope of the line and its vertical intercept. However, you can actually use this form given any two pieces of information about a line. For example, suppose we know a line goes through the points -1, 5, and 3/2, 2. In this case, we're not explicitly given the slope, nor were we given the vertical intercept. But if we take a look at the slope-intercept form, we can see that there are only two unknowns in this equation, m and b. Remember, x and y are necessary variables that have to remain in that equation. Anyhow, from our prerequisite work using systems of equations, we know that given an equation involving two unknowns, those unknowns can be found if we have two conditions. Now, you likely don't remember it being worded that way, so let me rephrase that statement. If we had a system of two equations involving two unknowns, we can find the unknowns. There is a caveat. Some systems don't have solutions, but that's not going to be an issue for us here, so don't worry about that. Now, you might be thinking, but we don't have two equations. Or do we? Let's go back to the original question and pretend that we're just starting. Taking a look at this, you can see they gave us 2 points, each of which has to satisfy y equals mx plus b. Thus, if we let x equal -1, we know that y should be 5. Alternatively, if we let x equal 3/2, y should be 2. And suddenly, we get a system of two equations involving two unknowns. Now, I'm going to solve this system using elimination. If you need to review solving 2x2 systems using elimination, please see the prerequisite link below. Subtracting the second equation from the first and cleaning things up, we find that m, or the slope, is equal to -6/5. Substituting this back into the first equation and, again, cleaning up, we get that b, the vertical or y-intercept, is 19/5. Thus, our equation in slope-intercept form is y equals -6/5 x plus 19/5. Notice that I didn't have to use the point slope form once here. This is a great example to showcase that given two pieces of information about a line, you can find the equation directly using the slope-intercept form. You do not need to actually use the point slope form. Now, this was an example where I gave you 2 points. What if I told you the slope of a line was -6/5 and a point on that line was 4, -1? Now, you might be saying to yourself, you've just given me a point and a slope, so why can't I use point slope form? It's true, you could, but I just want to show you that you could do something different and use the slope-intercept form. So instead of using the point slope form, we can just start with y equals mx plus b. There are two unknowns here, again, just m and b, but we were initially given the slope. So our equation is actually y equals -6/5 x plus b. This equation now only has one unknown, that's b. And we still have not used one of our given conditions, that the line includes 4, -1. So if we take that equation and let x equal 4 and y equal -1, you could see that we could solve for b. Doing so, we get b is equal to 19/5. And so the equation of the line having these two conditions is, again, y equals -6/5 x plus 19/5. This is a really cool way to find the equation of a line, and it is always an option when you think you should only use the point slope form. So I highly encourage you to exercise some creativity and perhaps go ahead and use the slope-intercept form when normally other students would use the point slope form. Thank you for watching this review video on the slope-intercept form of a line. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar or if it was confusing to you, then I recommend you click on the provided relevant prerequisite links listed below for further help. However, if you find you're continually doing this, you might want to consider speaking with your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.